Hello, this is Captain Chaudhari. In my series of videos on basic ship stability calculations, I was doing SFBM. I did SFBM of beams by a certain method, and then I did SFBM for box vessels by another method. Now I'm going to do SFBM for box vessel, but the method I'm going to use is the one which I used for the beams. Now here I'm not going to draw the curves. I'm simply going to find out the SF and BM at selected points. So let's do this question from my book. This question says that there is a ship 60 meters in length, right? Length of the vessel is 60 meters, empty ship. It is symmetrically loaded and it has got similar 6 holds, and the cargo is loaded this way. In hold number 1 and 6, 240 tons level trimmed. In hold number 2 and 5, 200 tons loaded in prism fashion, no slope in athwartship direction. And in the middle holds, 160 tons each is loaded in reverse prism fashion, right? That means the maximum cargo at the end and 0 at the mid length of the hold. Let us total down the cargo. So 480 tons from end holds, 400 tons from these 2 holds, and 320 tons from the middle holds. The total is 1500 tons. Now, what is the displacement of the vessel? Displacement is 1500 tons, and that is also going to be the buoyancy force. Buoyancy force is equal to displacement is equal to 1500 tons. So what is the buoyancy per unit length? Buoyancy per unit length is going to be 1500 divided by 60, and that is 25 tons per meter. Now you can see that the vessel in lightweight condition is symmetrical about the midship, and the cargo is also loaded symmetrical about the midship. So without any argument or calculations, we can say that the vessel will float on level keel. That means the draft is going to be same all over the length, and draft decides the buoyancy force from down. So can we say that the buoyancy force is uniform all over, and that is 15 tons per meter. Now if we treat it like beam, and if I want to find out what is the shear force and bending moment at this point, and this point, let us see how we can find out. First of all, to find out the shear force at this point, I want to know what are the vertical forces to the left and what are the vertical force downwards to the left. The upward force is given by the buoyancy, and buoyancy is 25 tons per meter and for a length of 20 meters, right? So let us say we are talking about a point A, which is over here. And at point A, the total upward forces, now we are doing the calculations for SF, total upward forces are 25 into 20, because this distance is 20 meters, right? This is positive force, and the negative force are going to be caused because of the light ship. Light ship is because the weight is 300 tons over here and length is 60 meters, it is 5 tons per meter. So at this point, the weight of 20 meters is 100 tons. The downward force to the left of point A is also caused because of the cargo, that is 240 and 200 tons. So the total is 200 plus 100, 300 plus 240. This is going to be 500, that is positive force, minus 540, and that is going to be minus 40, right? So minus 40 is the shear force at A. Similarly, let's find out shear force at B. Shear force at B is going to be 25 multiplied by 25, because up to here the distance till B from the forward end is 25 meters. So 25 tons per meter is buoyancy force. So total buoyancy force upwards is 25 into 25, that is 625. And downward force is going to be caused because of this 25 meters of the ship, which is 5 tons per meter, so 125. And also because of this 240 tons and also 200 tons and also half of this 160, that is 80 tons. So can we say it is 625 positive, and negative force is 125 plus 240 plus 200 plus 80. So this is 280 plus 40, 320 plus 2, 520, 620, 645 minus 645. So that is equal to minus 20. So we got shear force at B as minus 20 tons. It was 40 tons over. And let us find out now what is the shear force at C. So we are talking about 25 multiplied by 30, because the ship's length is 30 till there, and the negative forces are the 30 meters of ship's length, making it 150, because 30 into 5 is 150, and the cargo of 240 tons plus 200 tons plus 160 tons. So negative forces are 240 plus 160, that is 400, 400 plus 2, 600, 600 plus 150, that is 750, and it is therefore 750 plus minus 750, that is equal to 0. So we've got SF force at C, that is the midship, as 0. Now let us find out the bending moment. For finding out bending moment in case of beams, what we had done is the point under consideration is made rigid. The vertical forces to the left of the point under consideration would cause downward forces, would cause anti-clockwise moment. Anti-clockwise moments to the left are negative. Upward force, that means the buoyancy force, suppose we are causing a pivot here, the upward forces are going to bend the ship clockwise. Clockwise moment to the left are positive. So let us look at the moments that are caused. The upward moments are going to be caused because of the buoyancy force, that is 500 multiplied by, now we are talking about this point, 500 multiplied by the 10, right? And then downward movements are going to cause anti-clockwise, downward forces are going to cause anti-clockwise moment. Now, first of all, what is the weight of the ship over here? Weight of the ship is 100 tons, and that's going to act from a point 10 meters. In addition to that, this 240 tons, 40 tons, the distance from here is going to be 15 meters. And then this 200 tons, the distance is going to be 5 meters. So this way the downward forces are the light ship force, the cargo in hold number 1 and cargo in hold number 2. So these are going to cause the anti-clockwise moment. So let us solve this. This is 5,000, the clockwise moment, and anti-clockwise moments are 1,000. 3,600, and once again 1,000. This is 2,000 plus 3,600, 5,600. So net result is minus 600 tons meter. So that is the bending moment at point A, right? So we'll make a note of the bending moment at point A as minus 600 tons meter, and minus indicates the bending moment is hogging. It's going to cause hogging at this point. Now if we consider point B, the buoyancy force which is acting for 25 meters is 650 25 tons. But what is that uniform buoyancy force which is acting here? We are talking about 25 meters, right? So what is half of 25? 12.5. Because the centroid of that force, which is uniform, has to be at half length, so 12.5. So this much is the positive or clockwise moment, right? This is clockwise moment. Now negative moment, if we total up the negative moments, first of all, it will be caused because of light ship. So for 25 meters, the light ship is 25 into 5, 125, and once again it is going to act at a distance of 12.5 meters. In addition to that, we have 240 tons here, which is going to act at this point, and this is going to be at a distance of 20 meters from the point under consideration. Then comes 200 tons, and the distance is going to be once again 10 meters, and then it is going to be 80 tons. But what is the distance of the centroid from the pivot point B? We know the whole length is 10 meters, so half of the whole is 5 meters, and what is 2/3 of 5 meters? 2/3 of 5 meters is 10 divided by 3, that is 3.33. So these are the moments, anti-clockwise moments, Let us solve them. 625 multiplied by 12.5. That gives me 7812.5, right? And then minus, it is 125 into 12.5. That gives me 1562.5. 1562.5 plus 4,800. 2,000, and this is 80 into 3.33 gives 266.4. Plus 2,000 plus 4800 plus 156 2.5 8628.9 and minus 8628.9, and this is 7812.5. That's going to be 4. 816.4 minus. So the bending moment at B once again is hogging, and that is 816.4 tons meter. The positive moment at C is mid-length, that is 30 meters, and 30 multiplied by 25 is 750. So 750 is the buoyancy force which is uniformly acting, and we are talking about a length of 30 meters, so half of that is 15. So this is a positive moment to the left of point under consideration. Now the negative moments are going to be given by, first of all, the light weight of the ship. Half the light weight is going to be 150 tons. So 150 tons once again acting from a distance of 15 meters, that is negative. Then you have 240 tons. Now this 240 tons, what is the distance from this point? So that is 25 meters, multiplied by 25. And then you have 200 tons, what is the distance from the mid-length? It is 15 meters, so 200 into 15. And then you have 160 tons, which is at a distance of 5 meters. Let's do the calculations. So 11,250, right? And the negative moments are 2250, because 15 into 15 is 225. And then you have 6,240 multiplied by 25. Then 200 multiplied by 15 is 3,000. And then 800, right? So the total is 6 plus 3, 9,000, 11,000, 250, that is 12,050. 12,050 is negative, minus 12,050. And the positive is 11,250. And what is the difference? The difference is so you've seen this is how we have calculated the SF and BM at 3 given points, and the principle that was used was, we consider the vessel, consider the box vessel like a beam, and use the similar method which was followed in case of the beam. To find out the shear forces, we do the algebraic sum of the vertical forces to the left of point under consideration, and to find out the moments, we find out the clockwise and anti-clockwise moments to the left of point under consideration. And we found that the bending moment at point A, B, C are minus 600, minus 816.4 and minus 800 tons meter respectively. All 3 points are hugging, right? And in case we want the answer in form of kilonewtons meter, we will multiply these figures by 9.81, right? All negative means all these 3 points the vessel is hugging.